Welcome, class. And this time we are going to review chemical reactions. By the end of this video, you will be able to review the basics of a chemical equation, balance a chemical equation, list the types of reactions and distinguish between them, and calculate percent composition. Let's review the basics of chemical equations, including some vocabulary. So notice I gave you an example. This is how you make ammonia. N2 plus 3H2 makes 2NH3. You guys should recall that reactants are on the left, products are on the right. I like to think about a factory. All of the ingredients go into the factory and out comes a car. There's two different numbers you'll notice in an equation. There's coefficients and there's subscripts. Coefficients are the big numbers in front of a formula. Subscripts are the little numbers in the formula. Notice I have the states of matter listed, in this case gas. This can be very important in AP chemistry because when you're rating things like equilibrium, constant expressions, you only include aqueous and gas. So make sure you pay attention to these little tiny details that are often given in an equation. And the last thing I want to point out is sometimes you'll notice a symbol or words above an arrow. A triangle would mean that it requires heat. A word might mean that it requires a catalyst. So how do you balance an equation and why? Well, if you recall, the number of atoms on one side of an equation need to equal the number of atoms on the other side of the equation. And this is why we balance, to make sure we are following that law. You can only change the coefficient. You cannot change the subscripts. You can change how much you have, but you cannot change what you have. So notice there's a 3 in front of H2 and a 2 in front of NH3. So this equation requires 1 nitrogen molecule, 3 hydrogen molecules, and it makes 2 ammonia molecules. But you cannot change the formula. Multiply the coefficients by subscripts to get the total numbers. For example, 3H2. Well, how many H's do you have? 3 times 2 is 6. 2NH3, recall that 2 affects everything in the formula. You have 2 nitrogens and 6 hydrogens. So which element should you balance first? Well, sometimes it's just trial and error. Sometimes you look and immediately can tell what you need to fix. Other times it could be challenging. One recommendation is to take the element that is in as few formulas as possible and solve it first. Now this isn't a hard rule, but sometimes if you leave O's and H's until the end, they'll work themselves out. Sometimes that's not the case. Sometimes it is. Sometimes you just have to play around. Let's go ahead and do an example of an equation. I'm going to start with a combustion because they can be kind of tricky. The first thing you want to notice is that none of your atoms balance. And what you should do is start with the carbons. On the left you have 5, so let's write a 5 right here. You have 12 H's on the left, so if you put a 6 here, 6 times 2 is 12. Now you want to count your oxygens. Well, on the product side, you have 5 times 2 is 10, plus 6 times 1 is 6. 10 plus 6 is 16. So if you're like me, you're going to come over here and go, oh, well, I need to write an 8 right here. No, you don't. See that O right there? You already have 1. So you really only need 15. Well, what number do you put in front of the O2 to get 15? 7.5. But that's just weird. We don't usually write it like a fraction. So my recommendation is write what you want, which is 15, and then go back and double all your other coefficients. So let me erase these real fast. And this was a 5, so we're going to make it a 10. And this was a 6, we're going to make it a 12. And just because I'm being picky, I'm going to fix this a little bit. It's really kind of hard to write on a mouse pad, let me tell you. Well, did we balance it? Let's check and see. we did. Well, we can't talk about reactions without discussing the types of reactions. The first one I want to mention is synthesis. Your book calls it combination. Means the same thing. Just means that you have all these ingredients coming together to make a product. Notice you have plus signs on the reactants, but not on the products. It's like making a car. You have all these pieces that go into making a car, and you make a car. Decomposition is the opposite. We're going to break something down. So you start with one thing, and you end up with a whole bunch of things. You take my beautiful, lovely mechanical pencil. I have one thing. How do I make it into many? I crush it and break it into a bunch of pieces. Combustion has a couple of characteristics. It's always a hydrocarbon. That means something that's made up of carbon and hydrogen. It can have oxygens, sometimes it has nitrogens. But when it's just C and H or CH and O, you always add oxygen, always. And you always make two products, CO2 and water. The example I gave is cellular respiration, where we take glucose and oxygen and make CO2, water, and ATP. Then there's some odder equations. One is redox, and we're going to talk briefly about it here. We'll hit it again at the end of the year. But it's just where the charges change. One is a reduction, one is an oxidation. These are easy to find because usually you have something alone, like the Mg and the H2, and when you're alone, you are neutral, you don't have a charge. Obviously, H with Cl or Mg with Cl has a charge. If it changes charge, it's redox. Notice that same equation is also a single replacement reaction. Plus signs on both sides, somebody is always alone. Mg is alone, but on the other side, Mg has a partner, and now H is all alone. I know it's H2, but it's just H. Double replacement is where everybody has a partner and they switch places, plus signs on both sides. If you are with me for regular chemistry, you'll recall that I did single replacement as the single date swap, where two people go to the dance together and somebody goes alone and that person comes over and kicks the one person out and takes the date. Double replacement, four people actually go on a double date, and at the end of the night they realize they've gone out with the wrong person, so they switch partners and go out the next week with the other person. They might have been miserable, but nobody was alone. One last thing in this short unit. Let's talk about percent composition or percent by mass. Basically, what is it? It's the percent of mass belonging to each element in a formula. Let me give you an example. I'm standing on a scale with Joey and Johnny. The scale reads 500. I know I weigh 100 pounds. I don't. I'm just making this easy, okay? What's my percent of the total mass? Well, 100 divided by 500 is 20%. In other words, I am contributing 20% of the mass on the scale. So how do you do this for chemistry? Find the formula weight of a compound. So if you were doing H2SO4, you have two H's, multiply that by the mass of H, plus the mass of sulfur, plus 4 oxygens, add it all up, and you get the mass for H2SO4. Then to find the percent composition or the percent by mass, you use this equation. It's the number of atoms of that element times its mass divided by the total mass for the compound, multiplied by 100. Here's a quick example. Find the percent composition for water. Now, the way that is written, that means you find the percent composition for all the elements. If it would have said find the percent composition for H in water, then you would just do for H. But because there are two H's in water, you have to multiply hydrogen's mass by 2 and then divide by the total, multiply by 100, and you get 11.2%. Why did I only put 1 in for oxygen? Well, there's only 1 in the formula. So what do these percentages mean? It means that if you look at water, almost 89% of the mass for water comes from that 1 oxygen. Hydrogen is only contributing about 11%.